At this point, we've created most of the hierarchy for our asset. However, we'll now make 2 more primitives that will allow us to broadcast changes to our asset no matter where it is in our final scene. This new top-level primitive is called class. So let's take a look at the class section of our asset structure guidelines. In here, there's just 2 nodes, but they're going to be actually really, really important nodes, and there's going to be kind of a little bit to unpack here conceptually to just understand what's going on with this class primitive. So the first thing that we're going to do in here is we're going to use our primitive node, and we are going to create a path here, and I'm appending class to the beginning of it, and then using the this channel reference here to get the primitive path from our create component node. So that's just going to make this primitive path class high-res-pig, and we're using these underscores here just to kind of denote that this is the class primitive that we're going to be inheriting from. It's just kind of a little visual kind of indicator for it. Now, you can see here that we have parent primitive type set to none, primitive type to none, primitive kind to none. So there's no real information being saved here as far as those go. However, we do set the primitive specifier to class. And what the class specifier is it's an abstract primitive type that won't be composed in our scene by default. It's going as USD composes our scene, it's going to skip it unless it's specifically asked for by one of the child primitives in our scene. So in this case, like if we were inheriting something from that, then the child primitive is going to be looking at that and asking, oh, I need to grab this information from up there, and then it'll be added into the composition of the scene. And when we traverse the scene, it'll actually go into these primitives here. It'll go into these primitives and find them. Now, normally it'll just skip over these as if they're not even there. So it won't add any compute time to composing our scene. But when we do put something in here and start giving some opinions to our asset or overrides or things like that, we're going to then traverse into these and grab that information. So first, we're just setting up these primitives. They don't have anything attached to them right now. There's nothing really going on in here. They're just two primitives that don't have any information really. And this next node is going to be where kind of the heavy lift comes in here. So what we are going to do here is we are going to use a primitive path to inherit from this reference primitive path that we have set here. So what we're telling this to do, we're telling it to inherit from the first input, right? So we're inheriting along this first input here. And we're looking at a reference primitive, right? So we're looking to inherit from this class high-res-pig. You can see we're using high-res-pig kind of as our leaf primitive in that hierarchy. So here is our high-res-pig. That's where we're going to be looking to see if anything's there for us to inherit from. And the primitive that's going to be doing this is high-res-pig. So now if we look at high-res-pig, we should see that there is an inherit set in here. I'm just going to kind of adjust this a little so we can see it. So here you can see there is an inherit path set now. So that is what's going to be set here. So if we go up a level and come back, we'll see that this gets added in. So now there is this prepended item that's going to be looking at this class / high-res-pig. So we will be looking to see if anything gets defined in here. Now, right now, these are just strictly class primitives, so nothing's really happening there. It's not going to be needing to traverse in there. But if we do add something in, which we'll do just in a couple chapters here, you'll see that change will actually get sent into our pig asset and actually updated in our scene. And that's the real beauty of using this class primitive, right? So anything we put below here will look for the same structure that exists here. So if we did something on added a geo primitive underneath this high-res-pig class and say change the material assignment, that you could do, and it would propagate to all of these components that you've used in your entire scene. So it's a real easy way to broadcast a change kind of globally to all of your assets in your scene. And you can do that with any of this hierarchy here. So you could add materials to it, assign new ones, all sorts of different stuff in here that you could do. And it'll basically just look for that same hierarchy beneath high-res-pig. So it's almost like this primitive and this primitive are kind of linked together now, right? This one is inheriting from this one. And so anything you do below this one is going to look for this structure and then update it from there. You could also add new assets in, right? You could also add new geo if you wanted to. So there's a lot of different options that you can do there. You don't just have to write an override in there. You could write all brand new geometry. So class is a really, really powerful thing to use. And once we write this last file onto disk, we'll take a look and see how that's written in there in the next chapter. The last step of building our asset is to set some metadata and save our USD file to disk. This will be a relatively simple task, but there are a lot of customization options in this last step that could be utilized in your pipeline. Okay, let's take a look at the meta and write section of our demo file here. And we only have a few nodes in this section, so there's not going to be a ton done here, but there are some really important things that you can use to customize in this section. So let's take a look at kind of where we are and where we're going with it. So first of all, we've got all of our hierarchy set here. In the last chapter, we talked about the class primitive. We also have all of our hierarchy here with our proxy render purposes set and our sim proxy and our shaders and everything. So everything is working the way we need it to. Everything's looking good. So let's talk about these last couple steps here. So in this, we're going to do a configure primitive in this node here, and we're going to look at the high res pig, so our main top level primitive here. And we're going to add a couple things that are going to be helpful, especially to tools in LOPS that we can work with, such as like the layout tool or other tools that have more advanced UIs that can see asset names and things like that. So what we're going to set here is the asset identifier and the asset name. So in this case, these are both going to be saved into our metadata here. I'll just slide this over. And here you can see that we have the asset info, we have identifier and name both set there. So that's pretty much all that we're doing in here, but you can imagine that if you had more complex tools in your pipeline, you could set up versions, dependencies, all sorts of different things about this asset, all different pieces of information. You could add custom information here as well. There's a lot of, specific data that you could write for your pipeline in this kind of spot here. So something really powerful would be adding this metadata onto your assets and onto your primitives in your scene. So then in this next configure layer here, we're just going to make sure that we have the default primitive set, make sure we're setting our scenes up axis to Y, the meters per unit, just really basic stuff, but that metadata that kind of lives up at the top of our file, just to make sure that those are all set properly. The other place that you can see this being set here is in our root layer here. If we go back here, you can see the up axis is not set. When we come down here, the up axis is set. The meters per unit was set before, but just good to make sure that these are explicitly set. And we're not really doing anything else below this. So this is a pretty straightforward step here, just making sure a few last things are changed. Now we go down to this USD ROP that's at the bottom here. That's obviously going to write out our USD. In this case, our output file, we have our extra string at the end here, the SDF format args, and setting the format to USDA. Well, again, just a reminder, the benefit of USD is that the .USD format is that it can be saved as a USDA or a USDC internally, and you can switch back and forth without losing that name linking. So it's really, powerful to be able to inspect it as a, human readable file and then switch it back to a binary file if needed. A couple other things just to note. One of the things that we've set in here is the flattened SOP layers. That's kind of just in case anything is coming from SOP layer upstream. It's going to make sure those are flattened on save. Don't forget that this USD ROP is also going to run all of our configure layers, like this one here, configure material, or configure payload. It's going to run these save paths. So if there's anything up in this step or is coming through at some point, you just want to make sure that those are flattened. So that's just one little thing to keep in mind there. And then output processors is a really powerful way to be able to work with work with your USD and kind of organize it on disk the way you want it to. So one thing we have set is use relative paths. You'll see that in a second when we look at the file. And then also copy all assets to referencing layer directory. This is a really nice thing to set, because what this is going to do is going to look for all the references and output that into a subdirectory called textures. In this case, mostly what you're going to see coming through is going to be shaders and things, textures in our shaders. So that's a really nice subdirectory to set up. And it's something that some of our internal tools that we've created in Solaris actually do for you. You'll see in some of the coming chapters, we have some really nice tools to kind of automate some of this process for you. And that's one thing that it'll do, is put it into a texture subdirectory. And then that is basically it for this node. We're going to save it to disk, make sure everything's good. We'll just hit save to disk. And then let's open up the file and take a look at what's going on inside of there. All right, so we've opened our hierarchies.pig.usd file, and I just want to note that this is saved as a .usd. However, it is ASCII inside, so it's human readable. So it's a nice little benefit of having that .usd. So here's what we've built in our kind of top file on our asset. So we have just a couple things specified in here. We have our information up at the top, like default primitive, frames per second, up axis, all those things that we set. Now, my time code is set to 166 just because I'm on frame 166 in my timeline. That could be changed easily, but just happened to be where my timeline was for some reason. So not a big issue there, but just something to keep in mind. That's why it says that. Then here we're just talking about the top level transform called hierarchies.pig. The API schema is just saying it's a geometry model API, just meaning it's, geometry. Here's the asset info that we set up. The asset identifier is hierarchies.pig.usd, and here's the name, hierarchies.pig. Here is where we have the inherit set up, right? So we have the inherit from this class /hierarchies.pig primitive. We're also setting the kind to component, and we're then loading a payload, which is our payload.usd file. So that is the file that we can then load and unload in our scene for those performance optimizations. Here's also the extents of our asset that's on disk. The bounding box information that we can use to just draw a box around our geometry when it's unloaded in the scene. And then lastly, we're just creating the class primitive and class hierarchies.pig. So that's just those extra two primitives that are up at the top that we're going to inherit from if we put information into those that we want all of our assets in our scene to inherit. So lastly, I just want to say that you can see here that this / is basically just saying that these are relative file paths. And you'll see that throughout all of the files on disk, that anytime we have one of these paths, they are going to be relative. In fact, if we bring up something like our payload.usd, which just has two files, those are relative as well. So those are just /material /geo. So it's just the same folder, basically, just with geo.usda. So it's in the same folder as these, but just slightly moved. And also, if we had shaders or textures on our shaders, those would be in a folder right up here that'd be called textures, and those would be referenced up, a level, and then in the folder, and then that file name. So just something to keep in mind, that your files are all relative. So if you need to move these on disk and share them with someone else or move them somewhere, all these assets and things all these references will move with those files as you copy and move them on disk. So just a good thing to keep in mind as you're kind of organizing your assets. And next, we're going to look at how actually this inherit system works when we have that set up with the class primitive. Now that we have our asset saved to disk, let's take a look at how the class primitive works when we try to use it to broadcast changes to our asset. So I'm looking at the class inherits section of our example file, and this is going to be a little involved, this chapter. So we've got a few different branches to go through. So let's take a look at this and try to understand exactly what's going on here, so that we can see the benefits of using the class primitive, where it might be best suited, and places where you could actually have other options as well, just to make sure that we fully understand what's going on here. So let's start with a pretty basic example, pretty straightforward example. We're going to take a couple different pieces of geometry here. In this case, we have a torus, a box, and then our reference in our high-res pig here. So there's our pig. We're going to merge those all together into one, and then say use an instance geo to just kind of scatter these around. Now I'm just using the prototype primitives here to source from this geo primitive here that's a group, and it's just randomly selecting those, putting them down. You could change the seed if you wanted to, whatever. This is just a straight up instancer. So in this step, I'm just going to configure the layer and set a save path for it. That way we can kind of strip out the layout from the actual class inherits that we're setting up. That way we can kind of look at them in isolation and not all in one file. Next, we're going to come to this switch here, and I want to pause here and just reference something here that you might not be aware of, and that is kind of a neat feature in and of itself. I'm using this at class output to set my input here. And you might say, well, where's that coming from? Well, you can actually use this context options editor, which you can find under Solaris content options editor by right clicking on that. And here you can see that I've added in a context option called class output. So as I change this, it's able to switch to either side of this switch. And you'll see in a second why that's really helpful. So anyways, that's what's driving this switch. So now let's get into the actual class part of what we're doing here. So first of all, what I'm going to do is create just an empty hierarchy here using a primitive node. I have everything set to none and just define. That way we're making these primitives, but they don't have any types or kinds or anything like that set on them. So now we have our hierarchy all the way to geo. And the reason we need this is because if we're going to set a material reference here, make that relationship, we need to be able to set that on this geo node within our object here, right? We have our high-res pig, and inside of it, the geo is where our material reference is stored, right? So here's our, material binding. And so we need to do the same thing under our class primitive because we're recreating the same hierarchy that exists in our asset. So next, we're going to add in our shader, right? In here, there's just a purple metal shader. It's nothing exciting, just one Material X standard surface node that's kind of making a metallic purple color, just to make a pretty different visual representation of what's going on here. So we're just putting that into the class high-res pig material primitive. And so the reason for that is, again, we're recreating the hierarchy inside of our high-res pig asset and making sure that we're adding this purple metal in here. Now, if we come down, we'll actually see that is being, created in this prototype and also inside of all of our instanced geometry here, our instanceable references that we've created. So that's cool. So everything's working so far, that those class primitives are being broadcast into our actual asset. And then the last step is just to assign it, right? So we're just assigning the purple metal right here to the primitive class high-res pig geo. So we're assigning it right here. And you can see that this material binding has been created, and we are setting it to, the purple metal material. The other thing you can do is you can add geo. So here I'm just adding a sphere. This is just a sphere primitive, nothing exciting going on. But you can see that under geo we've done this add sphere to class, and that's now adding a sphere to all of the primitives here. So let's write this out to disk and, kind of take a look at what we're doing here. So here, this side is going to write our instances to disk, and this is going to write out our duplicates to disk. So the duplicates are in this other branch here. So we'll get to that in a second. But right now, what we're going to do is we're going to make sure that we're writing our instances to disk. We're going to save that. And when I hit save, if you look down here, our context options have this option name called class output, and it's set to 0. So every time I hit save on this, it's going to set this switch to 0. Every time I click on this one and hit save, it's going to set it to 1. So this is a way to actually drive things like switches and different parameters when you hit render. So you can imagine probably many uses for those context options. And it's a really nice little feature to kind of throw in here. And it's in a situation like this, very, very helpful. So let's take a look at that on disk. All right, so here is our instance layout that we've created. It's fairly straightforward, although it's a very long file because there's a lot of instances being created. We're creating instance geo, that's a group. Then we're defining our prototypes, and that's a group. Here we're saying these are all going to be set to invisible. And then here we define the geo transform again, and just say this is also a group. And then we start creating our prototypes that we're going to select from. So here's our torus. Here's our box. And down here is the high-res pig. And you can see that this is literally just loading a reference from disk here, right? So that's all it's doing. The rest of them are actually saving the geometry, which we could obviously have added another layer higher in our network here, and that would have just used that file and loaded that in. So, and then we're just creating a ton of instances here. In fact, I think if we go all the way to the bottom here, we'll see that there's really nothing else happening other than creating a bunch of instances. So there we are. That's our layout file. So now let's look at this instance example. That's the final file that's being written down here. And what we're doing is you can see we're setting up our class, our high-res pig, our geo. We're setting the material binding on that. And then below that, we're defining that sphere that we're creating. And then down here, we're setting up our material scope and our purple metal, and then all of the shader properties and things like that. And also down at the bottom here, we have a standard surface preview being made there. But and we're sublayering our instance layout up here. However, we're not setting any inherits in there, right? Because that inherit is already set up. So pretty much once we put these files in here, we're all good to go. Everything is being read by our asset, and it's flowing through the rest of the USD code. So you might look at this and say, okay, this is interesting. Like, you have this instance, but isn't there another way that you could do this using your prototype? And that is true. And I've set that up over here just so you could see that. So over here, we just have, so we're starting back from where we have our layout set up with all of our pigs. Then we could create our prototype shader here, and that would go down into our prototypes. We're not creating a class in this case. So if we look in here, this is creating the purple metal, same shader in our prototype. And then down here, we're assigning it to our prototype. So we're assigning it to this geometry. We're just updating this binding to purple metal. And now that has been changed to all your instances, right? So yes, you can do this kind of two different ways. So you didn't have to have a class primitive set up here, right? That's not necessary. However, you can imagine that if you had maybe multiple instancers or multiple things throughout the scene, using the class would be the more efficient way of doing it, because that would go to all of your instancers at the same time. So that is one way of looking at this, using something like instances, right? Now let's kind of pivot and look at if we were using kind of duplicated references and how that would look. So here I'm just taking the high-res pig, right, just off a disk, and I'm going to use a duplicate node. And so what this is going to do is create copies of each of these references on disk. So these are all their own unique references now, right? And I'm just going to save that duplicate layout right here as a USDA. And then it's going to go into our switch. Now here, if I want to change this, I'm just going to go into our context options and just change this to 1. And now that's going to be set on this side by default. So let's go back to our scene graph tree. So again, we're going to do the exact same thing here. Create our geo primitive, our hierarchy up to our geo primitive. Then create the material library. Then assign the shader to our class geo, right? So we're assigning the shader up here, and then adding the sphere to our class. So it's doing the same exact thing here, but remember that these are all individual references. And so what we're going to do is we're going to come down here and we're going to save this to disk. And we'll take a look at that as well. Let's take a look at the code of what's actually going on in there. Okay, so here is the duplicate layout version. So this is the one where we're using just the duplicate lop to lay out our scene. And you can see each of these references on disk are calling highres_pig.usd. Now some of these have transforms because we've been moved over, but pretty much they're all exactly the same. They're just bringing the USD file off a disk in each of these cases. And then the really interesting thing is that this second part of our code is identical to the instance example, with one difference, that it's sublayering our other USD file here. So we're sublayering the duplicate layout up here versus sublayering the instance layout. right here. So that is the real difference that we're seeing there. And the rest of it's identical. You can even see right here in this entire overview of our code that nothing changes except that one little element up at the top and our default primitive, because the hierarchy is a little different. So it's kind of interesting to think that you could create the entire second part of this network here. You could create all of this stuff here, and it would work no matter how your class primitive is, or how your assets are being assigned in your scene, which is kind of a really nice thing to think about, that you could create that file and sublayer it, and it would basically do the same thing no matter how your assets are being laid out in your scene. So it's a really powerful way of working. And just to make sure that we're really understanding what's happening here, there is no references happening at this point, right? It's not like we're referencing these high-res pig assets back to this one here. And we can kind of show that by setting up this duplicate shader, right? So here we're going to have this duplicate shader, same thing. We're making a purple metal material. And then if we wanted to assign that here, we're assigning it to high-res pig and high-res pig 4. And we can see that those are the only two that are getting it. So we could actually still save out some different shader assignments this way. So we still have the flexibility there, right, to be able to assign shaders that way. However, we have then at the same time the flexibility to be able to override all of them at the same time. So this is, I think, in a situation like this where you maybe have multiple references of the same thing in your scene, that in this case they're all just in a line, but maybe they're in a bunch of different places in your environment or whatever. You would be able to actually broadcast that change globally and still be individually referencing those from disks. The other thing too is like you might be in this duplicate node and think, oh, well, maybe if I do a reference, that's going to change things. However, it's the same situation. There's no difference here. Each of these are still able to be set. And then you might also think, what if I made this instanceable, right? Like, oh, okay, maybe these are all now looking at this high-res pig here. And at this point, we're going to get an error, right? Because we actually can't write into this pig 4 because it's instanceable. So we can't actually make that assignment in there. That's something we learned in our last course in this learning path. So if we turn this off, it won't be erroring, but now we'll only be able to change this first one because it is just a reference on its own. So again, this is, I think, really the power of the class setup. And hopefully this whole section will give you a better understanding of how to broadcast your changes in your scenes, and also what to do with the class primitive when you're setting up your pipelines. Now that we understand the structure of a USD asset, we can explore how using the component builder workflow in Solaris can make the process easier. These nodes will not create anything structurally different from what we did before, but packages all of the previous nodes into artist-friendly tools. So before we start actually working with the parameters on the component builder, let's just talk about the nodes that make up this workflow. So the first one is the component geometry node. And what that does is it takes it has a SOPNet inside of it where we actually can set up different geometries to work as our render, proxy, and sim proxy files. So we jump in there, work in a SOP network, create our geometry the way we want it to, and then that automatically brings that up in the correct hierarchy for USD and for Solaris. Then the component material is how we can apply materials and create variants. So what it does is it takes in a geometry on this first input here, and it takes in a shader reference here on the purple input, and that can be either a material library like it is here, or it can use something like a reference, a USD file from disk. That works as well. So those two inputs allow us to then take the geometry and take our materials and then apply them to different parts of our geometry that way. Also, for each of those component materials that are in our network, that will create its own variant in a specific variant set. We can set that within the actual component material node. From there, we take all of that and put it into the component output. And this is really all of the kind of USD ROP type things that we do at the end of any string of LOPS nodes. And it writes all of our USD to disk. It creates the file hierarchy, the folder hierarchy, and has just a lot of really nice controls for being able to save our USD files. So those are the 3 nodes that make up the component builder. And then if we want to talk about the files on disk and how those are made, this is kind of an overall structure of how the files relate to each other. So in this column over here, we have the extras, material, and geo USD files. By default, those are going to be binary files, so they're USDC. And all of those are referenced into the payload.usd file. And so that payload file is then payloaded into our asset name.usd, whatever the asset name we define is. And that gives us the ability to unload the files at this point here. So we can unload the composition at this point and allow for us to not have all of our geometry displayed in the scene. The one thing that's really nice about the component builder is that it does add on this concept of variant layers. And what we can do here is when we have a variant set created, whether it's a geometry, material, whatever it might be, you can take your variant set, and depending on how many variants are in that set, it will make a layer for each and every one of them. And you might think, oh, well, that's going to bake my variants down and I won't be able to switch them after the fact. Well, that's not true. What it does is it just sets an override on top of this asset name.usd. So everything that's in this, it creates just an override on that and sets the variant. Now, that still gives you all the variants to choose from after the fact, though. So you could very easily change those variants after you have loaded in the variant layer files. So it's just kind of an extra thing on top of the standard asset building structure. However, some tools like the layout lop in Solaris really work well with using variant layers. So it's a helpful thing in certain workflows. Let's now go into Houdini and take a look at how to actually work with the parameters on these nodes. All right, so we're looking at the component builder basics section in our example file. And here we have the same component builder setup that we showed in those diagrams. First of all, let's take a look at the component geometry. Now this will look really similar to a SOP import or a SOP create node. It has parameters here for different ways to handle attributes coming in, subsetting groups, different things like that to be able to set up how your geometry is being converted from SOPs into LOPs and into USD. There's also parameters for packed primitives, how to deal with those, and then any kind of advanced or custom information goes here. Now here's where it's setting the geo variant name. It saves that based on the name of the node. So we'll see in a little bit how we make geo variants using multiple component geometries. So let's jump inside and we can just see the network in here. And so each branch of this network will create different parts of our hierarchy. So here we're just bringing in a pig head, deleting some groups, setting it to the ground plane, then subdividing it here for the high-res version, poly reducing it for our proxy, and then doing a shrink wrap remesh for our collision geometry. So those will be our render, proxy, and sim proxy primitives in our hierarchy here that we can see as being, this is being built in our scene graph tree. So that is how the component geometry works. And one more thing to note is that if you did have any issues in here with these outputs not being there, you can press this fix SOP outputs, and that will allow you to, it'll kind of rebuild those outputs for you to use. You can also bring it from a file or from an external SOP. That's kind of up to you, but this is kind of the most, not robust way of doing it, but this is a way to give you a lot of control within that one node. The next thing we'll talk about is the component material LOP. And this takes in 2 inputs, as we said before. It takes our geometry in the first input and our shaders and materials in the second input here. And so in that case, we're setting up a material library with just a green material X material in it. And that is being assigned to all of the geometry that's coming in the first input. So the shader that's coming in the second input is being applied to all the geometry on the first input. That's what's being said here with the primitives and material path. Now you could specify the primitives and material path, but in this case, we didn't need to. Also up at the top here, you can see that this is the name of the variant material set that we're creating called material, and the variant name is just going to be the name of the node, which is just op name, in this case, just that expression. So that is the component material op. And finally, we have the component output. And this has a lot of settings that we can do with it as far as creating different hierarchies and changing the way that our files are saved. So let's just kind of go through it and we'll talk about each section kind of one by one. So here up at the top, we have the, it's saying what the source for our component output is going to be. In this case, we're using upstream component geometry, but there's some other options that we could use as well, like just some arbitrary setup of input primitives or a scene import. So there's some different options that can be used there. We're setting the root primitive. That's just the name of our component here, and that's being driven by the name of this node. And here's the kind component. Just leave that as it is. We can also set our default variants here. And under the advanced, we can go in and set up, our class for inherits, whether or not we're going to have that, which we talked about a couple chapters ago, and all of the metadata that might define what this asset's name is and where it's located on disk, things like that. So that's under the advanced section here. Then in the caching, this is just all the save to disk type things that we would normally get from a USD ROP output. So in this case, it's just saying the name of our asset, the file name. These are things that are going to be used in various places within this component output node. Also, there's the location that this is going to be saved on disk. And from this node, we can also load from disk. So if we save it and then load it, we can use that as a place to kind of cache out our information and be able to read from it. Then under this next section is the export options. This allows us to rename our files for payloading, geometry, all those types of things, and also the subdirectory where non-USD files will get saved. In this case, it's just called textures because that's probably the most common thing that will be non-USD files, but if there was something else, you might want to change the name for that. Finally, there's the up axis, meters per unit, and variant layers that we can set. The variant layers are what we had talked about just a little bit ago, where you can take a variant set and create a specific file for each variant in the set. So that's a really helpful thing to be able to do. And it also has a directory name where those files get saved. And then down here is just some information for metadata and then any context options that we might want to use when saving. We also talked about that in the last chapter as well. So that's where we would do that here. And then the very, very bottom here is the thumbnail creation for this asset. Now, we can set the resolution of our thumbnail. We can say what mode we want to use, whether we want to use a renderer or just the viewport or Houdini GL. And then also where we want the camera to be positioned. So in this case, if we come down here, we can see the view thumbnail camera. We can change where this camera is in relationship to our asset. So you can make a thumbnail that will better represent your assets when you're looking at it visually. So that is the component output. And the only other thing that you can do really with this node is dive inside of it. And in here, anything that gets added to this empty network here is going to go into your extras file. So if there's anything like lights or cameras that you want to save along with your asset, you can put them inside of this component output, and that'll be saved directly to that extras file on disk so that it can live separately from your asset, but alongside of it and be able to be moved around as you maybe pass this asset through your pipeline. All of that is the component builder. And in the coming chapters, we're going to talk more and more about how to create variants and the different ways that we can work with variants to create these options that we might want when we're creating our assets. Making geometry variants with the component builder is much more straightforward than it is using the lower level tools. In this method, we can simply wire multiple component geometry lops into a component geometry variants lop to create and name our variants. Okay, so let's take a look at our component geovariance section of our demo scene. And in this, we're going to put 3 different component geometries down in our network. Each of these is just going to have pretty simple geometry inside of them. We're going to have a pig head in one, we're going to have the toy in another, and we're going to have a squab in the last. And so what we're doing here is we're naming each of these, right? And each of these names are going to drive the geometry variants that we're making. So from here, we place down the component geometry variants node. And what this does is it creates a variant for each incoming geometry on this node. And here you can see that we're creating a variant set called geo. We could name this anything we wanted to. The source mode is going to be inputs. You could also have a specific number of sources that you might be doing. Now, there's also the variant name source. So this is taking the variant name from the component geometry inputs. You could also manually write this and create some variant names based on that. However, we're just going to do component geometry inputs. And then from there, you can also set the working variant, right? So we could say the squab is the working one, or the pig is the working one, or the toy is the working variant. We'll just reset that back to where it was. It's going to just randomly assign one. So we have our component geometry variants from this point. Here we add a cyan material. This is again just a simple shader in a material library. And this is applied to all of the primitives on this incoming first input. The second input is for the shaders. And then from here, we create our geometry variants, and it just basically takes each of those, makes sure that it's organized properly, and writes all this information to disk. And what we can do at the bottom here, well, first of all, let's save this to disk. So we have that saved. So that's going to be called our geo variants. And now we can add an explore variance down at the bottom here. And this is just in the explore variance mode. We have spacing, and we're using the bounds to kind of keep them spaced from each other. And in this case, we can see all of the different variants that we're creating. We are creating 3 different geometry variants, and they all get the same shader applied to them. So that's pretty much it. That's how you would make component geometry variants using this method. And let's take a look at the code now and see exactly how this is getting written to disk. Okay, let's take a look at the USD files that are actually being written to disk. Let's take a look at the code inside of them, and we'll find that there's some really interesting stuff happening here. So let's first start with the geo file, since that's the main thing that we're dealing with our component geo variants, and then we'll move through the rest of them and just make sure we completely see what's happening with our asset here that we're building. So first of all, the first thing you're going to notice here is that we have this asset geovariant 0 that's being made. So this is a primitive that's being made, and you can see hidden equals true is set. And so the interesting thing there is that we're actually creating hidden primitives. And this is just going to be in our geo.usda file. We won't see this in the end. We'll only see this in that first geometry file that's getting loaded. And from here, we're going to define a transform asset. We're going to set up a string, a variant string called pigvar. And we're also going to prepend our variant set geo, right? So this is going to be prepending our variant set. And then this here, we're saying in the variant set geo, we're going to add in this pigvar. It's going to be a component. We're going to define the scope geo. We're going to add in some extents and things like that purpose. And then here, we're going to define our mesh, which is a shape. And then down here is going to be all of our actual attributes for that mesh. So we're starting to actually build this kind of hidden, primitive structure we're going to use at the very end to do something really interesting. And there's a really good reason for it. And we'll see that in a second. So here we're building asset geovariant 0. It's hidden primitive. And if we scroll down here, we'll see that we're making asset geovariant 1, also hidden. Pretty much the same things happening here. The only thing we're changing out is the string toyvar and this toyvar in the variant set as well, and then adding in the properties for that, the point positions, things like that. Then as we scroll down, we'll see that we're also doing our squab variant here and adding that into the geo variant set. So all of that is all well and good. And then down at the bottom here, we can see that we're defining our geo variants, which is going to be the name of this asset that we're building. That's what we named the component output node. So therefore, that is what our asset's being named. And we're going to prepend references onto this. There's 3 references that we're going to prepend, and it's going to be the asset geovariant 2 asset geovariant 1 asset, and the asset geovariant 0 asset. And so what that's going to be doing is taking these hidden primitives that we're creating, and those hidden primitives have our variant set on them, right? And so we are then referencing those primitives with that variant set inside of them to our geovariance primitive. And the reason for this is actually really interesting. When we do this, it creates a reference. And if we remember our liver P's strength ordering, that's going to put this as an R. And if you kind of look back and think back to that in earlier courses in this USD with Solaris learning path, you'll remember that we talked about the LIVRPS. In that we have our V, and that's for variance. So V is higher than R. And so that means that if we had multiple variance sets being defined, they would all be living on the same strength, right? And what we want is for our geometry to actually live at a lower level, a slightly weaker opinion, so that when we put our materials, which are in variance sets, on top of that, and we compose that on top, that will then properly compose and have its own strength applied. So that is the reasoning that we're doing this. We're creating this as a reference to variance sets and using this hidden structure, and that allows us to make this as an R as opposed to a V strength. So that's the reason for that. And let's come back over to Houdini and just take a look at how this actually looks in here. I have this sublayer node. We're just going to sublayer in the geo file here. We're reading in geo.usda. And if we look here, okay, we're not seeing anything. It looks pretty normal. We've got geo variance, geo, and shape. But if we come up here, we can turn on show hidden primitives. And now we can see those extra hidden primitives that we created in here. And so if we look at asset, for example, we can see that this does have variant geo pigvar. So it only has pigvar set on it. This one has toyvar, and this one has squabvar. Then if we look down here at geo variance, this is where we're referencing those onto. So now those three references come together and form this geo variance set, and we have all three in there now. Squabvar is the one that's being loaded right now, and that's just because it's the last one that was added to the list. So that's why it's holding its strength in that regard. But that is what's happening inside of this geo file here. So it might look a little confusing when you see it at first, but I think once you start to understand that we're using that reference specifically in order to control the strength of our different variant sets, I think it should make a lot of sense, especially when we look back to that liver peas strength ordering. So let's now move on to the material file. This one's going to be, again, much more straightforward. We're not going to be really doing all that much here. It's going to be slightly different, but nothing too crazy, and we'll see exactly how this looks in a second here. But here you can see we have our asset material cyan. We're creating the material. We're defining the material here. So this is the scope material right there. We're defining the material cyan. We're defining our shaders and then properties of those shaders. And we'll scroll down. We'll see also we have our preview shader here as well. And then at the very bottom here, you can see that we're defining a transform called geovariance. We're prepending our reference to this asset material cyan. We're setting up our variance here to cyan. Then we've got our variance set here that we're creating called MTL. We're defining that scope, and we're setting our variance set on that scope. And really what this variance set is doing is controlling this binding, right, of this material cyan here. So that's really what's happening here. We're controlling the material binding in this case versus setting any type of reference to that actual material. We're just dealing with the material binding. That's in a variant set, so it gets that V strength, and so then that will make it stronger and make sure that no matter what geometry we're using, we're always composing this cyan material over that, or whatever material we might have. In this case, we just have one. So hopefully that is clear in this case, and you can kind of see how this works out for us. So those two files are both loaded by the payload file. They're loaded as references here. So we have our material and our geo file. Those are both here. So pretty bare bones file. It's just kind of there to allow us to reference both of those. And then that payload is going to get brought into our main geovariance.usda as a payload. So now here you can see that we're building kind of the last pieces of our asset. So we've got our geovariance transform. We've got some asset info here, like an identifier, the name of it, and a thumbnail, if you've made a thumbnail for it or had that saved. Also, we're setting up our inherits here for our class primitive. We've talked about that previously. What the kind is, which is a component. And then here's where we bring in our payload.usda. And then we're going to prepend our variance sets geo, And then here is all of our variants that are in that variant set. We have pig var, squab var, and toy var. So that's all of our variants for that. And then finally down here at the bottom, we have our class primitive that we're creating just that we can reference or that we can inherit from, which you remember here is where we do our inherits. So there you can see we have class geovariance, here's class, and then geovariance. So hopefully that that is all clear to you, and you can see how we're using those kind of different ways of doing things to make really strong assignments for our materials, and also variant sets for both our materials and our geometry as we're bringing that in to our assets. And in the next chapter, we're going to talk a bit more about how to do material variants only in this component workflow and how that looks in the files that it creates. Making material variants with the component builder is also much more straightforward. We make a library of shaders using the material library lop, and from there we add as many component material nodes as we need to create our material variants. Okay, so let's take a look at the component material variants section of our example file. And here we're just going to start with one component geometry, which is our pig. And this is going to be very basic, just our pig head with some normals applied, just to make sure that everything is coming in to our viewport properly. So that creates our pig geometry there. And then down here, we're going to have our material variants created, the different materials that we're going to use for our variants. And so here we're creating a red shader, a green shader, and a blue shader. And each of these are just a material X standard surface node with a base color set, basically. So nothing really overly exciting there. However, when we start coming down here to our component material nodes, you're going to see that we're going to be creating a material variant set that's called material. And so this is where we can call our material variant set. We can call this whatever we want. We could call it foo, we could call it bar, whatever. But in this case, we're just going to call it MTL. It's kind of just a default. It also matches up with the material scope that's created here in our scene graph tree. And from there, this is going to copy all of our shaders onto our asset here. You can see that it's copied all of these different shaders here for us. And each of these has the option to assign a material. So in this case, we're just going to be specifically setting our asset/geo, which is this primitive here, to our asset material red, which is obviously right here. And each of these component materials is going to do that. So this is going to create a variant called red. This next one will create a variant called green. And then finally, we'll have a variant called blue. And then we come down here to our component output. We can, inspect what's going on here. We can set defaults. We could set it to red, green, or blue here. We can set this to red, or we can turn this off and not set the default variant. In this case, it's going to default to whatever the last one was that we created, which in this case is blue. So let's just set it to red. Not really much else we need to do here. It's going to just save this file to disk and we can take a look at it. So let's go here. We'll save this to disk. So we'll take a look at that in 1 second, see what the file looks like. However, let's look at our Explore Variants node down here. And this is set again to the Explore Variants, and they're laid out side by side with a little bit of spacing. And we're using the bounds of our geometry in order to check, in order to make sure that they're close together, basically. And you can see here that obviously we have the red, the green, or the blue, the green, and the red variants created. So pretty straightforward what we're doing here. And so let's take a look at the actual file to see what's happening in there and just fully understand what we've created here in this with this component builder here. Let's take a look at the files on disk that we just wrote. So here we have our top level transform material variants in our material variants.usd file. So this is going to be our component that we're making. We can see we set that right here. We prepended a schema. Here's some asset info. Again, identifier, name, thumbnail. We're setting up our inherits, which is to class material variants, and those primitives are defined down here. And then we're also prepending our payload, which is going to payload in payload.usda, and we're setting the default variant here to red. So then if we go into the next file, we can see that the payload file just has our standard references to material and geo. So all makes sense there, nothing complicated. Our geo file is pretty straightforward as well. We're just saying the transform for material variance is here. This is just the name of the component. You can see here it's kind component. We make a geo scope with some extents, some bounding information and our purpose. Then we create a mesh, and our mesh has all of these properties to it, point positions, things like that, different prim vars. So that's our geometry that we're using, which in this case is the pig head. And if we go to the next file here, our material.usda, this is where things are a little bit different, right? Because we're making all of our material variants in this file. So first thing that you'll notice is that we have this thing called asset material red, which doesn't show up in our final component builder output. So that is something to consider there. That's a primitive that we don't see in the final scene graph tree. So let's just keep that in mind as we go through. So we have this asset material red, then we're creating a material scope. We're defining a material red, the shaders, which is a standard surface right here. We'll scroll down a bit. We'll also create a preview surface, and then we'll come down and create our next material. We're defining the material green, making our shader, and so forth. So far, we're just basically creating shaders and defining materials. So here's our material blue. Here's the shader that we're creating there. And then we come down here and we'll see we have our preview surface shader for that as well. So now at the very bottom is where the most interesting stuff is happening, right? So here we're defining our transform material variance, right? So this is going to be this is going to be composed on top of our top level primitive, right? And so we're prepending a reference to material red. So this is our asset material red that we created all the way up at the top here over asset material red. So now we have that way at the bottom here. We're referencing up to that primitive. We're setting what, the starting material variant is going to be here, which is blue, although that's going to be overwritten up in the material variance.usd. As you remember, the default there was red. So we kind of changed that up in that top level file, and that has a stronger opinion too. So then we're prepending our variant set material. Now we're defining our scope material, and this is going to hold the variant set. And in this case, this is what our variant set is going to be. It's going to have blue, which is going to go over geo and set this material binding to material variance material blue. Then we have green, which is again going to go over geo and set our material binding to green. And then red is going to set our material binding to red. So this is where all of our variants live. And if you remember in the last chapter, we talked about how we had set our geometry variant set to be a reference that holds variance. In this case, there is a reference, but the variants themselves are actually held just in this file. It's not anything that is the references aren't holding the actual variant set. If you remember in our previous chapter, these things up here, like up at the top, this would actually have our variant set. But in this case, we're just defining a shader. So we're just referencing in some shaders here, these three shaders, and then bringing those in and setting these bindings as what our actual variant set is. So really the variant is changing that binding. So that's the difference. Let's take a look at this in Houdini in the actual user interface, and hopefully that can help sort this out a little bit too visually. So here's the material file just being subbed in, material.usda, and here's our scene graph tree. We can see that we have that asset material red material, and then here's all of our shaders, right? So here's blue. We can look at the metadata here. We can see, nope, there's no variant sets being created there. There's no variant sets here. There's no variant sets there. So none of these have any variant information on it, just straight shaders. Then if we come down here, we can see material variants. This is where we're actually setting our variants, right? So now we have our variant material, and it's set to blue. We have blue, green, and red all in that variant set. And here you can see this is the geo. This is where our material binding is being created here, right? So we're binding to blue in this case. And then here are the shaders, that we're referencing from up here that are getting put into this, into our actual structure of our file itself. Now, or of our asset itself. This is going to overlay on top of material variant, which is the name of our asset. And we won't see this asset material read in our final component output, which if we come down here, sure enough, we just see that material variance right there. And that has our variant material set right there. So that is the difference between how working with geometry variance and material variance. That's really how they differ. And in the next chapter, we'll talk about doing both of these things together in one kind of component builder setup and see how that looks. One amazing thing about USD is that geometry and material variance can be used together to create even more options. Using the methods outlined in the last 2 chapters, we can quickly create 9 unique variants on our asset. So let's look at the multiple variant sets section of our example file here. This is going to look really similar to what we've done in the last 2 chapters as far as the node setup works. Nothing really too surprising here, but we'll just walk through it just to make sure that you understand what's going on. So here we have a component geometry called pig mult var, which just basically multiple variants. I'm just naming it that way so that my nodes have unique names. These will also end up being the names of our geometry variants. So here we have a component geometry of the pig, of the toy, and of the squab, same as we have been doing recently in these last couple chapters. Then we throw that all through the component geometry variants node that will set up each of those geometry variants that we're going to use and create here in our USD. And then next to it, we have a material library here that has an orange, teal, and fuchsia shader in it. Again, just super basic shaders, nothing really crazy going on here, just have a base color set on them. And then each of our component materials here are going to set the material path to each of those different variants that we're going to be using here. So in this case, we're setting it orange, teal, and fuchsia. And from that standpoint, we now have 3 component material, or I should say material variants that are going to be authored on our asset when we're done with this here. So those are all set. Each of these nodes is setting a variant, and then we bring it down into the component output, and this is called just mult variants. That's the name of the asset that I'm building. And so when we save this to disk, I'll just do that real quick. We're going to get, the standard files to disk. We're going to get our asset and then payload, geo, and material. Those are all going to be written out. We don't have any extras created, so we're not going to be getting that one. That would be if we put anything inside of this component output wired in there. That would be the extras. So let's use this explore variants to take a look at what we're actually creating here. I'm just going to kind of home this a little bit here and take a look at it. So here we have the 9 different variants that we're creating, right? Each geometry variant is going to have each of the material variants applied to it. So that just 3 times 3 is 9. Pretty simple math there. So you can imagine how quickly you could make more and more variants if you were doing something like this. Maybe you might have something that would have a little bit more unique shading needs. So maybe not every single one of the objects would get the same shaders applied to it, but you could figure out what the best situation there is for you. But in this case, we're just globally applying a shader to our objects and kind of going from there. In each of these component material nodes, you can select which primitives you're using. So you could have different primitive names or whatever that would be used in order to make sure that that's set correctly. You could use geometry subset names, things like that, to be able to change how you're working with primitives. And that kind of goes back a little bit to some of the other concepts that we talked about earlier, and using geometry subsets and bringing in different parts of your mesh as different named pieces or things like that. So there's a lot that you can do there in order to kind of customize this. You can have multiple material assignments in each of these component material nodes. So these are things we've gone over, but just to kind of reiterate that you could select this in a little bit of a more unique way, but I'm just doing this for example's sake. So that's really all that's going on here. We've got our 9 variants that are set, and let's now take a look at how the actual USD is structured there. And it should be something that we're familiar with from the last 2 chapters, but we'll just go into it and just take a look at it to make sure we know exactly what's going on. Okay, so let's take a look at these files and see kind of what's going on inside of them. This should all look really familiar, but we'll go through it again just to make sure that we really have the understanding of what's going on in these files. So here we have just our default information set up at the top here, up axis, things like that. Then we're creating our base transform here, multivariance. That's going to be the name of our asset. Here's our asset info, identifier, name, and thumbnail. So those are each being saved along with this information here. Then we set up our inherits. That's going to be looking to the class multivariance primitive. And here you can see we're creating our class multivariance down at the bottom here. So that's where that's being created. We're also setting the kind for this asset. We're prepending the payload. So that's going to payload in this file so we can load and unload it in the viewport. And then we're also creating a variant set called geo at this point. So here's our variant set geo that we're setting up here. It has the pig multivar, squab multivar, and toy multivar inside of it. So basically it has those three geometries inside of it. Those are all components, and set some extents for those so that we have bounding boxes and things like that when those are unloaded. So let's move on to the next file, the payload. This is, again, the standard way of doing it. It's just bringing in two references, one to a material, one to a geo file. So that's going to define our what we're loading in basically, and these are going to be referenced onto our multivariance primitive. So from there, we're going to look at the geo here, and we're going to see again, we're setting up that hidden primitive called asset geo variant 0. Then here we're defining transform asset. This variant is going to be pig multivar. We're prepending the variant set geo. And then here we're writing the information into that geo variant set. So here it's setting up pig multivar, it's setting up the scope geo, defining the mesh shape, and then all the mesh information. And it does this again a couple times. Once for the toy here, we see that it's starting to set up the toy here, and here's the toy. And then down at the next one, it's going to be setting up stuff for the squab. So those are the three geometry variants that we're creating. And then down here, again, we're referencing these in so that it has an R liver peas strength, and that way when we put the V, the variant strength from the material on top of the geometry, it'll make sure that it appropriately layers that kind of on top of it. It has a stronger opinion because it's a V versus an R. So just something to remember there, that's why we're doing that. We talked about that in the last chapter. So finally, here's our material file, and we have, we're going to set up the different materials that we're creating here. So first we're going to define the material fuchsia. So we made a scope and a material fuchsia. Then we're going to come down here, set up the material orange, and then we're going to come down here and define the material teal. And then at the very bottom here, we're creating our variant set here called material. We're defining the scope material, the variant set material here, and we have each of our, each of our different shaders that get bound. So for fuchsia, we're setting the binding to fuchsia. For orange, we're setting the binding to orange. And finally for teal, we're setting the binding to teal. So that's just changing that material binding for our geometry. And we're using that variant strength to make sure that that's stronger than than whatever we're setting in the geometry setup. So that's kind of how we make sure that strength comes through. And so that's pretty much how this looks from from the standpoint of the USD on disk. It's basically just a combination of the last two things that we did in the last two chapters. And in the next chapter, we'll take a look at how to actually kind of randomize this once we've got it maybe instanced around in our scene. How do we actually work with these and make sure that we can get some randomization from just this one asset without having to go in and manually set a bunch of things and just get a nice randomized result from it?